Example 5, f of x equals x squared minus 3x and g of x equals 2x plus 1. They want us to do the composition of g of f of x and f of g of x. And this is the notation the book really likes to use. It's an accurate mathematical notation. It's not illegal to use it. It's not very useful though. It's not easy to tell what they want you to do with that. All right. So let me give you a real expression here that might be more meaningful to you.
I think I recognize. Yeah, I was going to say I remember seeing that on the compass test.
Right. So you got g of f of x. This, what I have circled in blue, and this what I have written in blue are the same exact question. This is more meaningful in my opinion because it relates to stuff we've done before, where this is just like this little open circle symbol between two letters. I don't know what I'm supposed to do with that. So just know that this and this are equivalent, but this would be what you'd be more comfortable with. And what I want you to see about this g of f of x is anytime you see a function name of something, right? We're supposed to put that something in place of x in that function name. The something inside of this is f of x. Alright, so it's saying g, so I go to function g of f of x, which is this stuff here, right?
Yep.
So if I then write this, what I have in blue, into even a more meaningful expression, I'm actually doing g of x squared minus 3x. Right? And that's no different than stuff we've already done this year. We've done functional values where we had to stick some weird expression in for x, right? So if I'm doing g of that thing, I go up to function g, changing x into x squared minus 3x. So 2 stays 2, being multiplied by x's new expression, which is now x squared minus 3x. I'm replacing one object x with multiple objects x squared minus 3x, so I use parentheses around the substitution, plus 1. So notice that's g of x exactly as it was up there, except x has been transformed into x squared minus 3x. So I'm composing function f onto function g. Okay, so that's what I'm doing. And then I got to simplify. 2 times this, plus 1. So g of f of x ends up equaling 2x squared minus 6x plus 1. The other one asks me to do f of g of x. Okay, and again, more meaningful expression. F of g of x. So this time g of x is the object in the brackets. So f of g of x means I'm actually doing f of what g of x is, and g of x is this expression, 2x plus 1. And if I want to do f of 2x plus 1, I got to go to function f, which says x squared minus 3x. X squared minus 3x. But instead of x's, I'm doing 2x plus 1's, so 2x plus 1 goes here, and a 2x plus 1 goes here. Then again, I want to simplify as much as possible. I have a binomial squared. Following through the process, there's going to be 4x squared plus 4x plus 1. Square the first, double the product, square the second. And negative 3 times 2x and negative 3 times 1 makes minus 6x minus 3. Once I've simplified my parentheses, now it's just a matter of adding like terms. So I can say my final expression, f of g of x, is equal to 4x squared minus 2x minus 2. So if it just says g of f or f of g, they want f of g of x and g of f of x, okay? It's not numerical. If they get a number after that, which the next example you're going to see does that, it's actually even easier. All right, but that's as hard as these are going to get for now, polynomial functions. You know, if one of them is x cubed and you got to stick in 2x plus 1 cubed, now you got maybe a little bit more complicated multiplication, but still, it's not beyond your capabilities, it's just more complicated. I think this chapter only sticks to squares at most, so they'll look like this.